Okay, we're going to work on rational inequalities today. Normally when we have equations, we want to get x to one side and the equal side to the other, right? And if it's a rational equation, you also want to find the excluded values. Whatever causes the denominator to be 0 can't be part of the solution because that's where an asymptote. However, 1 degree higher of difficulty is it's not set, the inequality doesn't have 0 on one side. So that's the first task. So when you add 4 to both sides, the problem is 4 will not have that same denominator. So you're going to have x plus 16 over x plus 1 plus 4. Well, 4 will need the same denominator, so you're going to multiply top and bottom by the x plus 1. So that gives us two fractions can now be added together because they have the same denominator, and you have x plus 16 plus 4 times x is 4x, 4 times 1 is 4, and now in the numerator, I realize my 4's kind of look like 9, so sorry about that. Numerator, you can add like terms. So x and 4x, we have 5x, 16 and 4 is 20. And then x plus 1. And that is going to be less than 0. Okay, there is one other thing you could do. In the numerator, 5 and 20 both have a 5 in common, and if you do that, it'll make it, if you factor out the 5, it doesn't, the only thing it does is it helps you know where the values on the number line, because remember, with inequalities, it's about shading. So essentially, rational equations, inequalities, the graphs might look something like this, or the graphs might look something like this, or maybe they're down here, right? Something like that. What this is saying is, what this is asking is, where on this graph will the values be less than 0, right? So if this were the graph, this would be the domain values. Everything on that side of the graph is below 0. But now these funky graphs, so we don't know what they're going to look like unless we actually plug them into a calculator or take a lot of points to figure it out. So what they want to know is, where on the graph will the graph be less than 0? So you first have to identify your two critical values. So whatever zeroes out the denominator, so the opposite of 1 is -1, and whatever zeroes out the numerator, so the opposite of 4 is -4. So we're going to have these 2 points, -4, and that could actually be a solid dot, and then -1. And remember, that's where the asymptote will be. Like if you were to actually later graph this. And notice, because this is less than, when we do the domain values, everything, all 3 regions, so there's this area of the number line, there's this area, and there's this area. And those are the intervals, not regions, intervals. So this interval is from -infinity to -4. The middle interval is from -4 to -1, and then from -1 to positive infinity. All right. So this is largely most of the work. But now you have to figure out where it's less than 0 and where it's greater than 0. So this is what you do. You're going to pick 3 values. So an easy number less than -4 is -10. An easy number between -4 and -1 is, I would pick -2. You can pick whichever number you'd like. And the easiest number greater than a negative would be 0. If that would have been a positive 2, I probably would have said 10. But since that's, or if that would have been a positive 1, I probably would have said 10. But that is a negative 1, so the easiest number is 0. Then you're going to plug these 3 red numbers into, you can do it right here, or you can do it right here. I'm going to choose to do it here. So look at what we have. We have a positive number on the outside of parentheses, and then negative 10 plus 4 is negative 6. And then down below, negative 10 plus 1 is negative 9. And notice I just put the signs. A positive times a negative is a negative. A negative divided negative is a positive. Is a positive number less than 0? False. So in this region, the graph will not be below the x-axis. So we can rule out that interval. Okay, now we're going to put negative 2 into, we still have that positive 5 on the outside. Negative 2 plus 4 is positive 2. Negative 2 plus 1 is negative 1. Now look at what we have. Positive divided negative is a negative. Is a negative number less than 0? That would be true. That means this interval, so somewhere in the graph, that works. So my guess is, I don't really know what the graph could be doing, but maybe if it's coming from up here and then it's headed towards there, maybe it looks something like that. I mean, I don't know. And then, so my guess is when we plug 0 in, it will be false. So let's try. There's a positive number on the outside of parentheses. 0 plus 4 is positive. 0 plus 1 is positive. Is a positive number less than 0? False. So in this case, your answer would be negative 4, negative 1. All right? I'll do another one where it's a little bit different.